Hello everyone and welcome back. In this video we are going to explain machine learning in a simple and visual way. We will understand what machine learning is, how a machine learning project works step by step, and some important concepts like data cleaning, encoding, bias, and via bias voice variance and the different types of machine learning. This presentation is based on the slides from Machine Learning Explained. Firstly, we start with a reminder of what is machine learning. Machine learning is a branch of artificial intelligence that allows computers to learn patterns from data without being explicitly programmed with fixed rules. Instead of telling the computer, if this happens, do this, we give it the data and it learns automatically from examples. For example, spam, email detection, price prediction, image recognition, recommendation systems, and insurance risk prediction. We move now to the machine learning process. So we have a lot of I can say 5 steps to follow in any machine learning model. First one is data collection. We collect data from databases, sensors, websites, Excel files, images. So good data is the foundation of every successful model. Number 2 is data preparation. We split the data into training data, validation data, and testing data. This helps us evaluate whether the model can generalize new unseen data. Step number 3 is data cleaning. We clean the data by handling missing values, removing duplicates, detecting outliers, and correcting errors. Clean data improves model performance significantly. And step number 4 is feature engineering. Here we create or transform variables to have the model better understand the data. For example, extracting age from a birth date, calculating a contract duration, or converting categories into numerical variables. Step 5, model training. It's the final one. We train the algorithm so it can learn patterns from the data and makes predictions. And we move now to the data preparation and splitting. So before training the model, we divide the data into 3 parts. The part number 1 is training set. It represents 70% of the size of the data. For example, if we have the data contains 100 rows, we get 70 rows to train the data. This is the data used to train the model. The model learns relationship and patterns from this data set. The validation set represents also 15% of the data. This data helps tune hyperparameters and improve the model during the development. And the final one is the testing data. It's only in the end. We use it to evaluate the final performance. The testing set should remain completely unseen during training. So we can have the idea of a good model should perform well not only on training data but also on new unseen data. Now we move to data cleaning. Data cleaning is one of the most important stages in machine learning. Even the best algorithms may fail with poor quality data. So we have firstly missing values. Sometimes information is incomplete. We might replace missing value with the mean or median, or remove rows depending on the situation or in your study. Secondly, remove duplicates. Duplicate records can be the model, so we can have an interfitting. So we remove repeated rows to improve data quality. Now we talk about detect outliers. Outliers are extreme values that are very far from the rest of the data. So, for example, extremely high interest claims, abnormal salaries, or unrealistic price, like we can have a negative price. It's outliers. We remove it, obviously. We study whether these values are error or real observation. Future selection. Not every variable is useful. We keep only the most relevant features to improve model accuracy and reduce complexity. Now we move to integer encoding was one hot encoding. Machine learning models cannot directly understand text categories. We need to convert categories into numbers. Integer encoding, for example, USA number 1, Mexico 2, Canada 3. The problem here is that the model might incorrectly assume that Canada is superior than Mexico and Mexico and Canada are superior than USA. But countries are categories, not ranking. So we have one hot encoding. Instead, we create one columns for each category, USA, Mexico, Canada. Each row contains a 1 for the correct category and 0 for the other. This avoids creating false numerical relationships. Now we move to Yes, voice variance finding the balance. This slide explains the balance between model simplicity and complexity. Firstly, we have underfitting. We have underfitting, it means high bias. The model is too simple. It cannot learn the important patterns in the data. Performance is poor on both training data and testing data. And our goal is to have a good fit, a balanced model, learn useful patterns, generalize it well, and performance well on new data. Finally, we have overfitting or high variance. This model the model here become too complex and memorize the training data. It performs very well on training data but poorly on testing data or maybe also in validation data. In real world applications, overfitting is a major problem. And we have the last slides, which is the type of machine learning. There are three major types of machine learning. Firstly is supervised learning. We have input data and known output labels. The model learns to predict outputs from inputs. Example, price prediction for detection, spam classification. Number two is supervised learning. There are no labels. The model tries to discover hidden structures and patterns. Example, customer segmentation, clustering, animal detection. And lastly, we have reinforcement learning. The model learns through rewards and penalties. It improves its decision over time based on feedback. Application include robotics, game AI, autonomous vehicle. And lastly, I will talk about key takeaways. Let's summarize the most important ideas. Machine learning follows 5 core steps: data collection, preparation, cleaning, feature engineering, and training. Number two, data should be split into training, validation, and testing data sets. Number three, one hot encoding is usually better for categorical variable. And number four, good models avoid both underfitting and overfitting. Number 5, the choice between supervised, unsupervised, and reinforcement learning depends on the problem and the available data. So here I can say that to you. Thank you for watching. uh, I can say that thank you for watching. In future videos, we will move from theory to practice and build real machine learning models steps by steps using real data sets. And thank you, and don't forget to subscribe and click in the like button. And goodbye. See you soon, guys.